Well, Dr. Rondeau, I'm really excited to catch up with you here at Mobile World Congress. I must say, the Akudu announcement's the talk of the show. Maybe you can take us through some of the broad strokes of what your goals are with Linux Foundation.
Yeah, so it's been a long time coming for us. We've been working on this for a while, understanding the need for opening up the RAN stack. This is a trend that we see in technology all the time. As soon as part of it becomes the processing and compute power become advanced enough, and the infrastructure is commoditized, it's the right time to grow into an open source stack. Because I didn't want everybody to kind of just keep putting their resources into building their own version of a RAN, carrying their own code around, and all the there was just so much like churn and resource being used for that. Well, it's like everybody had their own operating system, and then Linux came along and said, "Hey, we can solve all this for the infrastructure of what became has become the internet." We wanted to have that same kind of transformation here of making sure that people could share the burden of the core of the RAN and really start to get those exciting ideas for what we can do with them. 5G is all trying to be transformative in different verticals, different use cases. We need to push that model there, and then have people figure out, okay, how do we actually deploy this onto novel hardware systems or size, weight, and power constrained systems or whatever the customer use case demands. And really, what I'm excited about is all the things that can fit on top of a stack like this, all those new applications. I'm glad you said, I think OCUDU has gotten a lot of attention here. Obviously, AI has been, that's the buzzword wherever you go. The one that keeps coming up in my week here has been Isaac, this integrated sensing and communications concept, which is going to be enabled by AI. We're also really excited about what OCUDU can do for Isaac, because we're going to need a lot of different ideas for different ways we can use for sensing. How do you actually use the RAN, hold the data, make sense of the world around you? I mean, these are all coming together, and I think we're building that foundation of the future of 6G.
All right, a lot to unpack there, so I might kind of break that up a little bit. You mentioned the hardware piece of it. I think given the newness of Akudu, there's a bit of conversation around how to think of this in the context of Open RAN. So roughly 8 years of development work to write the specs and do the integration so that carriers can have optionality and build a multi-vendor RAN. Hasn't gained a ton of market share, but has certainly some notable nation-level deployments, including AT&T in the US. So by no means a failure, but how should we think of Akudu relative to the work that Open RAN has done to this point?
Yeah. If you'll forgive me a little bit of historical context here, I'll tell a story that I've told many times before, but at a conference, keynoting a conference in 2017 when I was working at DARPA, the Defense Advanced Research Projects Agency, and they invited me to kind of finish up the talk, and I gave a talk about what we're doing at DARPA and all the RF and signal processing stuff, cool stuff. And I finished that talk with what I thought was a joke, which as I walked through all of the original Star Trek movies, and then I walked through the generations of cell phones, I said, what are the common, what's common between these two things? Only the even ones are good.
I like it.
So basically I was saying 5G is likely to be a failure. And that in 2017, when everybody was looking at 5G as the savior of telecommunications, was a very unpopular thing to say. Now it seems to be kind of common wisdom in the community that 5G, but I wouldn't call 5G a failure. I wouldn't call Open RAN a failure by any means. These were necessary transformative steps to get to where we need to go next. The odd generations tend to be revolutionary ideas, and the even ones, the good business cases that are made out of them. 5G was a transformation of the industry into a software-focused industry. Open RAN was part of that architectural shift by saying we've got to disaggregate, we've got to open these systems up, we've got to figure out how those interfaces connect to each other so that we can actually have different subsystems talking to each other in a common way. That has worked. People now understand how this telecommunications network architecture can be thought of in a software fashion. But like we did in software-defined radio, which was looking back at the hardware implementation of a radio, and we implemented that hardware piece in software. And then kind of at one point, a few of us woke up going, why are we limiting ourselves to how we did it in hardware? We all went back to the old textbooks and said, the math tells us what to do. All we're now constrained by is the computational power and the idea of computable numbers. So kind of all of that led to this more transformation in software-defined radio of a software focus. We're doing the same thing with OCUDU. It's taking the lessons learned from Open RAN, taking the successes of Open RAN, and then growing them into a fully software-defined stack that can be deployed across multiple different hardware platforms, and take that next leap into a fully transformative software-defined industry that will lead to 6G and all those use cases that can then be built there to accelerate the growth and the adoption of all of this. So if you're using Open RAN today, and you've sunk your business and your ideas are going to be developed in Open RAN, the shift to Akudu is going to be pretty natural for you.
Okay, very good. So to expand on that point, if we think of the RAN as a platform for software-based innovation, and you work with your partner ecosystem, you work through Linux Foundation, generally, what kind of milestones would you be looking for in the next maybe 2-3 years? And how would you gauge success?
Yeah. Ultimate success is we have one or more, what we would call a term of systems integrator. So somebody is actually selling a solution to a telco somewhere around the world that is using OCUDU as its base system. It doesn't need to be branded OCUDU. OCUDU is not the full end solution itself, but so we need to package that up. You need to deliver capability to the customers. So we want OCUDU to be part of that, and that's going to be the ultimate success for us. Because what's happening now, so again, I come from the Department of War, so we're a U.S. government department. We have our funding lines, and Congress has given me the support to push this forward by putting the money from my office into OCUDU. But we are not the long-term sustainment model for something like this. I'm a research and development guy. We work under the Office of the Secretary of War for Research and Engineering. So we're building that platform, the prototype, the base of this code. And importantly, it was because even though industry has identified that they want to be a part of this, we talked to them for a while. They really want somebody to do something like this. And if you look at the OCUDU Ecosystem Foundation, the number of people we signed up for the board, we both premier and general members, it's pretty incredible how people have really kind of jumped on this and how fast they jumped on it. Everybody seems to want something like this, but who is going to kind of take that initial risk and put the actual money in it to grow this? And we said, that's where the government does come in. That's where we do have a role, offset that risk. So we're putting money into this. We have 3 years of runway for government funding of this. And at the end of 3 years, they have to be commercially successful. Okay. By which they have to have enough support and enough interest by the industry that industry is paying to sustain this, making sure that it is a well-maintained, well-governed open source code base. All right, so that's the kind of trajectory of where the money's going. In the meantime, the announcement Monday was the OEF, the OCUDU Ecosystem Foundation. That was the big deal of saying we built together the industry partners, the initial cohort of industry partners, I should say. No one is excluded from joining at this point. So the Linux Foundation will continue to push that. But basically come out and say, yep, the OEF is here. That was a big milestone for us. Another one is the code is already on GitHub, so people who are savvy enough can already go find OCUDU out there. But version 1, officially stamped version 1, will come out in April of this year. So that's going to be a big deal to make sure that now we actually have the solid code that we're going to rely on. And at least right now, the plan is under my contract with DeepSig, the company that's running this for me, and SRS, the sub company that's doing the core of the code. Every 6 months we'll have a code drop. I shouldn't say a code drop. Every 6 months we'll have a new version release.
Okay.
But the development of the code will be done in an open source fashion. So you'll see the code being developed on GitHub, regularly updated as it's going. But then we'll kind of snap the chalk line and say this is version 2, this is version 3, or however they version it. A question that we have is really how fast is that fast enough? Is it too fast? How do we make sure that it's that we're tracking both trends in the industry, technology, but maybe not pushing too fast that people can't keep up, and make sure that they get solid products built on top of it. So those are some of the biggest things that come to mind.
All right, so you talk about success as a function of commercial viability, and you mentioned your launch partners, among them Ericsson, NVIDIA, Nokia.
Yep.
Ericsson and Nokia, they've built the business selling integrated RAN. NVIDIA seems to have a fairly specific vision for AI RAN for 6G. Help me understand what these market dynamics are in terms of cooperation or competition.
Yeah. That's a really good. That's one of the good things about an open source project, and one of the reasons why we chose this path. And also, I should say, give credit to Linux Foundation. We chose them as our partner because we've seen them do this many times before with different sub foundations running different technologies. There's always that kind of dynamic of who's in, how they're working together. The way that I look at open source software is it's not really a technology decision. It's a business choice. Do I open this? Do I not? Do I keep it proprietary? And so you should make a selfish choice of whether or not that works for you, or what should be open and what should be proprietary. And you should really only, in my opinion, I'm not trying to tell companies what to do, but in my opinion, you should focus on keeping the proprietary code, the thing that is a business differentiator for you. So what's unique about your solution, what's innovative about your solution, and then the rest of it is just architecture that you're sitting on top of. Why spend your resources handling that when everybody could? So people should make a selfish business decision on their use of Akudu or not. So when I talk to people like Nokia and Ericsson, yeah, they're the traditional RAN vendors. In one sense, though, they are in heavy competition, not just with each other, but with Huawei. And the trends are not looking good for that kind of Western technology. If we just do the status quo, and even if we just try to do more of the status quo, not really going to affect the way the market trends that we're seeing today. Yeah, they know that they've got to do something different. One of the opportunities, though, is because OCUDU can codify, literally in code, the technical specifications and can actually drive them to actual technical success. When we build an app for OCUDU, and if you've built your proprietary stack with those same interfaces, then the marketplace of all these Isaac applications, all these new AI edge applications that fit OCUDU, just go straight onto you. So it exposes you to more market opportunities, acquisitions, hiring, purchasing of products that can actually, again, make you a better service for your end customer. And I'm using kind of these business terms, but for me, my end customers are like my warfighter, the military services that we need to man, train, and equip is their requirements. How do I make sure that they're getting the best technology? I need openness so I can actually do analysis and monitoring of it. But I really need those ideas to go. How do I transform my communications networks that I can deploy with my service members and give them opportunities to create differentiating capabilities in the fields for them to do their job and create a more sustainable and a more more survivable warfighter.
Yeah, you've mentioned integrated sensing and communication a few times, so I want to kind of take a look at that a little bit. We talk about 6G, what do we envision as a general use cases? For me, it's ubiquitous connectivity that can be leveraged as like an inferencing fabric for physical AI, and then sensing and communication. Turn the network into a sensor, know where things are in time and space. Both of these are highly relevant to modern warfare. Yep. So I'd really love to just kind of hear your perspective about how Department of War is thinking long-term about leveraging 6G and those capabilities.
Yeah, and there's a lot there. So let me see if I can constrain myself from getting a little too excited. One of the things, again, I'm going to go a little philosophical to begin with here. I'm well known for my math tattoos all over my body of all the signal processing and physics and stuff like that goes behind all this. Because what the math tells you is that there's an overlap of communications, computation, sensing. They're all kind of one and the same, and we piece them apart because some of the physical realities of how we build things has had to keep them apart. But there's merging towards capabilities that overlap now in the hardware and the systems, and of course now in the software that can process all of this information and make sense of the world and communicate. I see the future of 6G. Really, what 6G represents to me is the combination of AI with edge compute, cloud compute, and the fabric to communicate all those together. So it's going to be a seamless. It's really going to be a choice of when do I compute, when do I communicate, and in a distributed fashion. That's all going to look like kind of this, so you say, fabric of computational resources that are going to have different qualities. Maybe the more I'm willing to push back on the cloud, the higher quality I can get. The more I'm willing to do at the edge, the lower latency I can get to solutions. So that's what's coming in here. Then Isaac is this idea of sensing. The fact that we have all these transmitters across many different frequency bands and different bandwidths, and all that plays into radar theory, but there are signals that are bouncing around the world here. And then we have a lot of receivers out there in our base stations and our phones that are collecting all of those reflections, and the information contained in that contains a lot of information about the world around us, the way it's propagated, and so on. And then how do we make sense of that inside these devices? So handful of things have happened in the past kind of couple decades when people were thinking about, well, this isn't really possible. Now again, physics says it is, but what happens in a base station today, or in a cell phone or cellular transceiver today, is you bring in a whole bunch of signal bandwidth, and then you try to cut that down as quickly as possible to get to the bits, because as you cut it down, it's more energy efficient. You don't want to carry all this extra stuff around with you. But it's all that extra stuff is what contains the information about the physics around physical world around you. How do we make sense of that? So advancements are a lot more spectrum has been allocated to the cellular world. And again, radar tells us that different bands, low band, mid band, high band, millimeter wave, etc., they have different properties for us. So we can use those to our advantage. Lower frequency, longer propagation, see further, but less fidelity. Higher frequency, shorter distances, higher fidelity. How do you actually pair those together is interesting, and now we have the opportunity because of all the spectrum that the 5G and future and 6G world will have. Second, we've had a lot of advancements in microelectronics and silicon or semiconductors, both for the hardware to be able to absorb all of this information, and the processing to take advantage and do that, to make sense of that information portion of it. And then finally, you got AI. And I think AI is going to be really instrumental in a lot of the future of this Isaac processing. A lot of the tests we're seeing, a lot of kind of classic radar models that we're seeing people adopt within early trials of Isaac, they work, they're going to work, it's going to tell us something, but there's a lot of limitations to that. What we call clutter, especially as we're like low down, we're looking into the world, all those bounces are clutter. How do you tease apart everything in there and do it in a densely connected network of systems? It's going to be a really interesting problem set to have, but huge opportunities because that densely connected network of systems can also provide you with a different way of thinking about radar processing and how to pull this together.
Yeah, I'm resisting the urge to fall off a mathematical cliff here, but I mean, if I'm reading this correctly, and for those of us in a niche of a niche, there was some pushback on the 3GPP using 5G waveform for 6G study, and in the context of Isaac, there's probably a better waveform to do that on top of Akudu, though you might have the opportunity for some optionality, right?
Absolutely, and that's the thing is, if you have that kind of open programmable system, then yeah, you're not constrained, especially as one of the things my office is looking to do is help build out infrastructure of highly capable compute boxes that can run OCUDU, that can do Isaac processing, that can do AI at the edge, and those are just ripe for software upgrades. And then you can, optionality. It doesn't necessarily have to be constrained by the standard. It's one of those things. The analogy that I use is probably too geeky of an analogy, but I think an RCR audience will understand this. It's how we negotiate encryption between, as you make a call or you make a connection on the internet. I'm going to come at it, military. I need the highest possible encryption that I can get. So I'm going to say, can you support this really tough encryption? Maybe say I can't support it. All right, can you support this next one? Yeah, I can support that. We negotiate that up front. You can negotiate the waveform too in the future. And so something like, I'm going to call them Cohere. They've been around. They've been pushing their OTFS model for a while. It's unlikely to become a part of the de facto standard. Maybe it's an option. Probably not at this point. We're looking at it. We can prove that out, and if it works better, if it provides better capabilities, get people interested, and then they can kind of generate the next generation from there. And really stop. To me, it's stop being held back by the standard and really start pushing the standard into new directions.
Excellent. Well, this is all really exciting stuff, Tom, and I would ask you for any summary thoughts and any kind of call to action for our audience, because we got a lot of people watching that I know are interested in what you're doing.
Yeah, no, and I appreciate the opportunity here and to talk to your audience and come walk through this. These are incredibly large scale, really new ways of thinking about the world. I think 6G is going to be super exciting for all that. But to get there, we really need usability of these systems. And I truly believe that OCUDU in an open source model is going to help us. We're going to create like developer kits and educational tools to be able to deliver to universities, research institutions, labs, so people can quickly get access to the code, understand it, use it, build their own base station. We're going to build the next generation of the workforce of telecommunications on top of the stack. The people who are going to know the intimate role of AI in computation and communications infrastructure. Importantly, though, we can't do this alone. We've built the OEF as a way to help industry drive the technology trends of the future of OCUDU. But we also need that developer base. We have SRS is going to be the core developers of the code right now. DeepSig is really creating that AI inferencing understanding of how it's all going to fit together in this 6G world. But you can't rely on an open source project if you just have a concentrated set of developers. You need more. We need to grow that as quickly as possible. So I really urge everybody, especially anybody who's been successful in Open RAN, should really take advantage of this as a next iteration, build on top of that, and help us create that the community, build the ecosystem, and build commercial success because of that, which is then going to fall back on use for me from a military perspective, saying, that's awesome, I can see that, I can secure that, I can instrument that, and I can use it for my unique purposes too. So it is a feedback cycle that we're looking for as we get this going. But we need as many people as we can to really take on the challenge and work with us on it.
Excellent. Well, Dr. Rondeau, thank you again for your time, and really congratulations on the announcement.
Thank you. Appreciate it.